Okay, so page 8, yesterday we looked at how we can calculate the enthalpy change if we're given the mass, the specific heat, and the temperature change. And our units for that end up being joules. And we could have a positive number or a negative number depending on the temperature change. So if the final temperature is lower than the initial temperature, then we end up with a negative number for our temperature change. And then that would work out to be a positive value for our enthalpy. All right. So heat of combustion is our last topic in 17.2. So the heat of combustion is the heat of reaction for the complete burning of 1 mole of a substance. The heats of combustion are reported as the enthalpy changes when the reactions are carried out at 101.3 kilopascals and 25 degrees Celsius. And then we're going to move into section 17.3 to finish out our notes today. All right, so 17.3, we're going to look at heat in changes of state. All right, so the molar heat of fusion is the heat that is absorbed by 1 mole of a solid substance as it's melting to a liquid. So it's changing from a solid to a liquid, and it's how much heat has to be absorbed in order for that change to take place. All solids absorb heat as they melt to become liquids, and the gain of heat causes a change of state instead of a change in temperature. And the temperature, as the substance is undergoing the change, actually remains constant. So there's these little plateaus that occur when it is changing state, and so it is able to absorb the heat, and that is what is causing the change of state. All right, so the heat of fusion is what it's referred to as an object is transitioning from a solid to a liquid, and then the next plateau is at the latent heat of vaporization, where it changes from a liquid to a vapor or a gas. And then we're ready for the next page. All right, page 9. So the molar heat of solidification is the amount of heat that would be lost when 1 mole of a liquid substance solidifies at a constant temperature. The heat of fusion and the heat of solidification are exactly the same thing. It's just, is it absorbing heat or is it losing heat to go from a solid to a liquid or a liquid to a solid? Okay, so when it's going from a solid to a liquid, it's called the heat of fusion. When it's going from a liquid to a solid, it's called the heat of solidification. All right, the molar heat of vaporization is the amount of heat that's required to vaporize 1 mole of a given liquid at a constant temperature. A liquid that absorbs heat at its boiling point will become a vapor. The opposite direction of this would be condensation, and it's how much heat is released when a mole of vapor condenses and goes from that gas stage to the liquid phase. When a vapor condenses, then heat is being released. The quantity of heat that is absorbed by a vaporizing liquid is the exact same quantity of heat that's released when the vapor condenses. So an application of this, the energy is required to vaporize or evaporate a liquid into a gas. So when you have liquid sweat on your skin, it's absorbing the energy from your skin, and it allows the temperature of your skin to decrease. And so the evaporation of sweat off of your body actually helps remove heat from your body. All right, so a graph of what this looks like. All right, so again, those plateaus are where it's changing state. There's a much longer plateau between the liquid and the gaseous state, or the gas to the liquid state, whereas the plateau between the solid and the liquid is smaller. All right, the heat of solution occurs when you're dissolving something. So it's how much heat it will take to either, it can either be released or absorbed, depending on if it's an endothermic or exothermic reaction. There is also the heat of formation, which looks at the enthalpy change that happens when a mole of a compound is formed from its constituent elements. It's assumed that this would take place at 25 degrees Celsius, and then the pressure would be 1 atmosphere, or 101.3 kilopascals.